Alright, hi guys, so here is video 6.2 problem solutions. Let's get started. Alright guys, so let's get started. So recall back in that first video the thought process that you go through when you approach a problem. So when we look at it, does this have just one function in it? Yes, it's just one function. Is it squared? No. Okay, so we can solve it like a linear equation. Alright, so I'll pop to the next slide and show you the rest of the solution. Good job if you got it. Here's the answer. Okay, so notice we're solving it like a linear equation. So I'm going to add 1 and then divide by 2. So we get cotangent of x is equal to -1. So you want to think which angles in our interval that we're given is cotangent of x equal to -1. And if you refer back to the unit circle, okay, that'll help you. Refer back to your unit circle, you'll recall that you can think of tangent because tangent of theta is equal to -1 at these same places, and since your cotangent is 1 over tangent, you can look at where tangent is and notice that tangent is -1 at these two angles here, at 3 pi over 4 and 7 pi over 4. Now, how do you know whether you're supposed to use degrees or radians? And a good indicator for that is what your interval is given to you in. So this was given to us in radians, so our answers should be in radians. Now, also, generally when you're given your angle as x instead of theta, your answers are going to be in radians as well. Alright, so number 2, determine the solution set in degrees. Alright, so like I just said, in degrees because we're given theta here, and also because the problem says it, for this problem. So when we look at it, you want to first say, is there just one function? No, we've got two different functions. So, and it looks kind of like quadratic in form, but we have secant and tangent here. So, think about what your first step would be, then go on to the next slide. Alright, so to make it quadratic in form, we're going to use one of our identities to do that. And we're going to use the identity, our Pythagorean identity. Okay, so I'm just going to write a note, use your identity here. And then you're going to set it equal to 0, just like in all the other problems, which is important. And then factor. And solve your equation. So now this is where it gets kind of tricky. This side here is easy because we have an easy problem. We can easily find our angles for where tangent of theta is equal to -1, and we know that's at 135 degrees and 315 degrees. But this side is where it gets trickier, right over here. Okay, so what is tangent of 3? Now you have to use section 6.1 again with your arc tangent. Okay, so you're using your tangent inverse. We want to find our angle. Okay, so making sure that your calculator is in degree mode because we're dealing with degrees. You will go and use the function tangent inverse of 3 here, and you get 71.56 degrees. So, if you look at this diagram here, you can see that our 71 degrees is in this quadrant, right? And now we know also that for tangent, it has a origin symmetry. So, tangent of tangent of theta is equal to 3 at 71.565 degrees, and also here at 71.565 degrees plus 180. So our other angle for it is going to be 251.56. Okay, and if you were to add another 180 degrees, you'd get another value where tangent of theta is equal to 3. So this problem, generally you think, what is our solution set? And you would take the 4 values that were given. So we have theta, first theta 1, theta 2, 3, and 4, but that is only, that solution set is considering only for 0 to 2 pi. Okay, and this problem says determine the solution set. It doesn't say only in theta 0 to 2 pi. It says for all values. Okay, so we're thinking all values. So you need to realize that our all values would just indicate that you're going to have a repetitive instance. So you start with your first value, so 135, and then we know that every time it goes 180 degrees, that you're also going to have that same value. Okay, so then we can write that as 135 degrees plus 180 times n. And then same thing with your other function here is you will write 100 or 71 degrees 0.565 plus 180, because every time you go around it reiterates. And if you want to a little bit more of an explanation, you can see the unit circle and look at that and see how when you have, such as right here, when we have 1/2 and then square root of 3 over 2, we also have that same value down here, but it's the opposite. So we'd have negative 1/2 negative square root of 3 over 2. Now when you're dealing with tangent, though, tangent deals with your y over your x, so these are essentially the same because your signs cancel out. Alright, so number 3, and this one is just like your example number 5 in the book. So what you want to do when you look at this problem here is think, first off, do I have one function? No. Does this look quadratic in form? No. So how am I going to solve it? And this is where you're going to, and you kind of think, well, what identities could I use? I don't know any identities for this problem. So think about it, and when you kind of feel like you don't have anywhere else to go, that's when you, I start to think, let's try squaring it. Let's try manipulating the equation. Alright, so in this problem here, I know that I have an identity that cotangent squared plus 1 is equal to cosecant squared of theta. Okay, so if I square both sides, that's a good start. So go on to the next slide, and it'll fill in those white spaces for you. Okay, so after squaring both sides, you can follow the algebra down. Pause it if you need to take a second to do that. So follow your algebra down, and then we get to the point where we have the fact that cotangent of theta, or cotangent of x, is equal to square root of 3 over 3. So looking at, you should have this one memorized. However, if you need to, you can refer back to your unit circle to find that value. Or you can also put it in your calculator to check it, but you're not going to get an exact answer. So we know that cotangent of pi over 3 and cotangent of pi over 4 is equal to square root of 3 over 3. So I did say that right. This is the fact that cotangent of pi over 3 is equal to square root of 3 over 3, and the same fact with pi over 4 pi over 3. Now, this is the trickiest part of this problem, is because we squared both sides, we have to check for extraneous solutions. Alright, and I'll give an example of that in class on exactly why you need to check for extraneous solutions. But to do your check, you're just going to plug back in your values. Okay, so plug in your solutions into the original equation. Okay? And then you'll do the algebra to check, and you'll see that this one is only differs by a sign. So this is not a solution, okay? And this is a solution because we see that it's verified. So our solution set only holds one value for this problem, and that is 4 pi over 3. Alright, our last problem, and this one is the most deceiving of all of them, because if you look at this problem here, you first off think, okay, we have more than one function, so Not going to use that. Also, you might think, oh, well, maybe I can just simplify easily, and I can go and I'll just divide by cosine. Don't do that. Don't divide by cosine of x, okay? And we'll talk about this in class as well, why you can't divide by cosine of x. Instead, what you want to do, and you'll see it in the next slide, is set your function equal to 0. Okay, set it equal to 0. Because then what you're going to do is you're going to be able to factor it and solve for your zeros. Now, I have kind of two options here. At this point, you can kind of factor it different ways. You can go and use your identity, because we know that sine squared x minus 1 is equal to cosine squared, so then that gives us the same equivalency that it'd be cosine of to the third of x equals 0. Or you can go down here, and actually you can also think of this, you can solve this one as well as sine squared x is equal to 1, so then sine of x is equal to plus or minus the square root of 1. So then you need to find what x is, and you're going to get two solutions just like we did here. So there are a multitude of ways that you can solve this, and all of them are correct. So in this problem, again, it says to find all solutions. Okay, so all your odd, and you realize that here that we have the same problem here. Okay, so the same thing. These are all the same answers. Now, we're trying to find all the solutions. You want to look at, what are we trying to find? We're looking at when cosine of x is equal to 0 and when sine of x is equal to plus or minus 1. And we know that that happens, that's going to happen on up here and this and here. So on our y-axis. So our solution set is going to be any odd multiple of pi over 2, just like we've done before. Okay, so we'd write out our solution set, which simply means the solutions to our problem, because this is a conditional equation, so it works for some values but not others. All right, and we write our solution set as the odd multiples. This symbolizes odd numbers of pi over 2, where n is any integer.